Hi, I'm Jacob Cybulski. How about learning some machine learning with SAS Enterprise Miner? Come along. In this lesson, you're going to learn how to set up your very first SAS Enterprise Miner project. Usually before you start working with SAS Enterprise Miner, you need to set up 3 folders. One folder for projects, I call it SAS YouTube projects. One which will be a folder for SAS7b files, which are SAS data sources. And I have the third one where I'm going to keep different files obtained from the internet. And in this particular project, I'm going to look at the data which you could obtain from the Kaggle website. And this is the data about the Titanic disaster. And I downloaded files which describe passengers and whether or not they survived the disaster. So let's go and create the first project. We'll start with SAS Enterprise Miner, and usually that first step takes a bit of a time. I call it the Titanic project, and I need to navigate to this very folder, which at the moment's got nothing. So let's go there, browse, and that usually takes a while. SAS pulls a lot of information from its templates, sets up the directory, and that folder will be created and seeded with important information. It also puts away some information in its internal database. Now, since Enterprise Miner is utilizing Java, at this point some Java processes start as well. So I'm going to go to that folder I just created. It's in my libraries, development area, SAS YouTube projects. This is the place. Open, and I'm ready. Next. At this point the folder creation started. While it's crunching, we could have a look at the data. The data has the following information. We have passenger information, the name, sex and age, whether any siblings were on board or parents, the ticket number, or which may have some other symbols, amount of money people paid for the place in a cabin. We could have a specific cabin number, and where they embarked on the ship, which city. Most important thing is that which class they boarded, which is actually standing for socioeconomic status of the passenger. And of course, have they survived or not, which is coded numerically as 0 for no and 1 for yes. Okay, so looked like it's all been set up. So just click, and you can see that a project should be created here. Here we are, the Titanic, and a lot of extra files, so that's why Enterprise Miner was so busy at this point. Now, normally what we do for each project is set up its library, but I'm going to import the data from CSV files, so I don't need the library. All I have to do is to create a new diagram, give it a name, the Titanic 1, in case I want to do another diagram later on, which I will in the next lesson. And while it's actually crunching, let's have a look. Above the diagram, I have a number of tabs called Sample, Explore, Modify, Model, Assess, Utilities, High Performance Models, Applications, Text Mining, a Time Series. The first 5 are interesting because they stand for description of the typical SAS methodology, which starts with sampling the data, exploring data, modifying it, modeling and assessing, and that's what we're going to do. Now each of those tabs consists of tools which are called nodes. When we go over each of the nodes, we have a little pop-up describing the functionality. File import is what I want, and I'm going to import the data from the Titanic folder. Once I put the node on my analytic process workspace, on the left I see all the properties of that node and the properties I can change. The most important one here is to import file, and I should import it from the computer. I'll browse for a file, and again let's go to the place where I got it from. It's my SAS YouTube data, Titanic training open, and I can read it in. That was very quick. At the moment I haven't read the data yet. I simply create the link. If I run this node, and I can run much more complex processes, that's already a process. The data is being read in, and the first few hundred records are being inspected, and from the data SAS is trying to figure out what kind of variables I'm reading in, what are the statistics, and basically it constructs a meta model for those variables. I can look at the results, which for this node are not exciting, but we can find out how many observations I've read in. There's 12 variables and more information, including information about the type of variables SAS figured out what it is. So what we're going to do first is to have a good look at the variables that SAS has read in. Here they are. Levels are sort of types of those variables, and let's have a look quickly and closely in those variables. Survived. This is the variable which we're most interested in. It will be our target or dependent variable. So I'm going to change it. It's not going to be used as input, it will be a target. Its role will be to be a target for our modeling. It's a number, 0, 1, but really that number defines a class. People survived or not. So I'm going to change it as nominal. So the target is a categorical variable. We have passenger ID is defined as input. Really we should not be creating a model based on the values of these variables. So I'm going to simply specify an ID. Name is probably not a good variable's input. I'm going to reject it. And maybe the cabin where people live in maybe should be rejected. Anything else I can reject here? Maybe the ticket number, not very important. And the rest, let's have a look what they are. So I'm going to say Control click for each of the input variables and a target. I selected them, and let's explore them. So the first thing really nice about SAS is that it allows you to look at the variables, the distribution, the nature, and some statistics of all the variables we have to deal with. We can also look at the data. This is the data, whether people survived or not, which class they were in, their sex, age, number of siblings and parents, the money paid for the tickets, and the port of embarkation. The age has interesting as good dots every so often. It means that some data is missing, and we may have some other missing data somewhere else, and we could verify that by looking at the statistics. As you can see, embarkation variable has some missing data, and the age as well. And for some models I may need to take care of this later on. I can see also from distributions the gray bar it indicates missing data. And you can see here it's a tiny little sliver in embarkation area. Okay, let's OK. And what can we do now? If we were to build a model such as decision tree or neural network or regression, we may need to have a look closer at the data. So let's look closely. Let's explore it. We have a number of different possible tools for data exploration. Let's look at the statistics of the data we read in. And very quickly, I'm going to run it. It's a good first impression of what type of data you're dealing with. Stat Explorer, it gives you some really good insights. The most important one is which of those inputs are useful for prediction of the target variable. And that's important that we defined the target a moment ago. Let's look at the results of this. And here we are. The variable worth. It's similar to correlation, but it's more than that. It takes into consideration not only numeric variables and the correlation with the target, which is nominal. It also looks at the chi-square of class variables or categorical variables against the target. So it's a different type of a measurement, very similar to both chi-square and correlation. It looks at the probability that those variables are in any way related to the target. According to this, sex is the most promising variable, the most associated with the target, then fair, p-class, age, and Parchin embarked the list. With all of the results, the visualization is simply the graphic representation of the data which is shown in the output. So let's build a model, and depending on the model we have to deal with, we may need to get rid of missing values, we may need to normalize distributions. We're going to use decision tree, which does not require much at all, but what it will require is to partition the data into the component used for training. We use 70% of data for training, and we'll not be testing it independently, but we use 30% of the data for validation, just to see if we're doing the right thing. And then let's create a model, decision tree model. I'm going to link it in, and all three streams of data for training, validation, testing are going together into the decision tree, which may utilize those three components somehow. I'm not going to do anything here, simply run it. You can run any path of the tree, of that process, the model, analytic model I'm creating. And therefore I can actually develop the model step by step, incrementally, test it one bit at a time, look at the results, reflect on it, change it, and go back to it. As you can see, whenever there's a tick next to the node, it means that the data has been cached for that part of the model. And so usually a check is done that nothing changed at that point, and the system will proceed to the next node, dependent node. If you have multiple processes on your machine, all of them will be used in a complex model to go through the data concurrently. And here is the result of my computation, and I'm going to explore it more in the future lessons, but let's look at the results here. We can see the misclassification rate in training was around 18%, and during validation it slightly improved. We have 16%. This is the first thing we look at in checking whether the model was developed properly, and if you have any good results coming out of the modeling and prediction in this case. First model, setting up the project, we're done. More interesting things in the future lessons. Thank you.